Welcome to solverfy.
So this question is asking us to name each of the following compounds, which I have already gone ahead and drawn for us on the screen. So we'll start with problem A. So just in general, when you are naming a compound, you want to start numbering each of your carbons, starting with the carbon that is closest to the branching to find out the length of the longest continuous carbon chain in the compound. So I'm going to start with this carbon because it's closest to the branching, and it's going to be number 1. This is 2, 3, 4, 5, and 6. So because the root chain is 6 carbons long, we know right off the bat that we're going to be looking at a hexane. The second thing we want to look at is each of the substituents and their positions. So if we look in the second carbon, we have 2 methyl groups off of the second carbon, and we have a third methyl group that is branched off from the fourth carbon. So I'm going to summarize their positions in the name. We have 2 methyls off of the second carbon, 1 off the fourth, and because we have 3 methyl groups, this is going to be a trimethyl hexane. And that is the name of compound A. Now for compound B, we see that we have what looks to be a methyl branched off of this CH2 over here. But in reality, if you just straightened out that bond, they would essentially be in the same chain. So we can start numbering at this end. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Our longest consecutive chain is 9 carbons, which means our base or our root is going to be nonane. And we just have to look now at the substituents. I've already said that the compounds at the end don't really count as substituents because, again, they're on the end. You could literally just straighten out those bonds and it wouldn't really change the structure at all. But if we look over here, we do have a methyl group that has branched off the 5th carbon. So I'm going to call this compound 5 for the position, methyl because that's the substituent, and nonane is the base. This compound is 5-methyl nonane. And now we'll look at C. So in this case, again, we'll look at our longest carbon chain, and it is 1, I'll write in black so you can tell my markings. 1, 2, 3, 4, 5 is our longest. So this root here is going to be a pentane for a 5-carbon chain. And it looks like we have 2 methyl groups off of the second carbon and 2 off the fourth carbon. So 2 on the second, 2 on the fourth, and that's going to be a tetramethyl pentane. And I'm going to write this part just a little bit better so that you can actually get the spelling. That's tetramethyl pentane. And that is the name for part C. Lastly, with D, we'll follow the same process that we have been. We aren't going to start numbering here though, because if you look, we actually have a longer carbon chain if we start here. And we want to start with the longest carbon chain that's closest to the roots, or closest to the branching. So that's 1, 2, 3, 4, 5, 6, 7, 8 is our longest carbon chain. So we know that this is going to be an octane. And now we have to look at the substituents starting from this first carbon group. So 1, 2, 3. At our third carbon, we have 2 groups that have branched off. We have an ethyl group over here, and we have a methyl group over here. So to name this compound, we're going to say we have an ethyl in the third position and a methyl in the third position, and our root is octane. So because there are no substituents besides those 2 groups, our name for D is 3-ethyl 3-methyl octane.